how's the studying going?
It's awful. I don't understand anything.
Why is that?
It just doesn't make sense to me.
But it was your choice to drop out.
I know, but I just don't get it.
Alright, well you need to pass this GD test, so I know who to call. Uncle Ted, he knows his stuff.
How's it going? Long time no see.
It's been a long time. How are things?
Pretty good. So I heard you're having trouble with some math.
Yeah, this whole dropping out of school and now deciding to get my diploma again. It's not easy.
All right. Well, what's the main thing you're having some trouble with?
Well, I'm into the grade 12 functions unit. I'm into chapter 8 and I'm struggling with composite functions.
Oh, all right. Yeah, I'm pretty good at that. I can give you a few tips if you want.
Okay, sure.
All right. All right, Dan. So you've learned 4 ways of combining functions, right? Already in your studies, like sums, differences, products, and quotients.
Yeah, I understand those.
All right. Well, this is very similar. Like another type of combined function occurs when one function depends on the other function. All right. So for example, like in a predator-prey situation, you know, the relationships between the predators and prey, the predator population is likely to depend on the prey, right?
Yeah.
So, and it's his primary food source. So think about the effect on the predator population when its food source is plentiful versus when it's kind of scarce.
Okay.
You know?
Yeah, I see what you mean.
All right. We'll do a couple questions on the board.
Okay.
And I'll make a little explanation for you.
Okay.
I'm going now. It's okay. Alright, Dan, so here we have a composite function. It's not too hard of a composite function, but we have y equals f at g at x, right? So f at x equals x squared, and g at x equals x plus 3.
Okay.
So we're combining these functions in a composite function. So here to get f at g at x, we already had the function f at x, right? And it's all in the brackets, so f on the outside, so we have to square the outside of the brackets, right?
Yeah.
And then we have g at x in the middle still.
Okay.
So g at x equals x plus 3. So we have to sub in where we see a g at x, x plus 3. So we have x plus 3 squared.
Okay.
So we FOIL it out, and we get a function here,
Yeah.
and it's x squared plus 6x plus 9.
And then once he gets there, you can do perfect square trinomial.
Oh yeah, there you go. Alright, Dan, so here we have another example, right? Are you kind of getting it now? Like,
I'm starting to understand, but I think if we do it more, I'll really understand.
alright, so we have the reverse kind of what we just did. So y equals g at f at x. So g at x is still x plus 3,
Okay.
and f at x is still x squared. So instead of putting the f on the outside, we have the g on the outside. So the g was the x plus 3. So think of this as this is still the x of the g at x, right?
Yeah.
So we have x plus 3 here, right?
Yeah.
So now we have the f at x function as the x for g. Okay? So what was f at x? X squared, right?
Yeah.
So we sub the x squared in for f at x, so we have x squared plus 3, right? And then we remove the brackets, so we get x squared plus 3.
I understand.
And that's the final.
Wow, this is awesome. Thank you very much, Ted.
No problem.
Dad, I got my test back. And take a look.
Wow, 99%. Great job, son. Great job.